We're going to talk about the history of the periodic table and what information we can gather from the periodic table. So first, several people tried to organize the elements that were known into some sort of type of organization. Some of them tried to do it in triads, which means groups of 3. Some of them tried to do it in octets, which is groups of 4. But it wasn't until Mendeleev tried to organize the periodic table that we get what is resembled today. So Mendeleev in 1860 is credited for the first periodic table. He arranged it by increasing atomic number, which was not correct. Our periodic table is arranged by atomic number, not mass. So he was wrong in that aspect. However, he had elements with the same properties in the same columns. He left spaces for undiscovered elements, and he predicted the properties of those undiscovered elements. So again, because he did it by atomic mass, it was not 100% correct. So some elements were out of order, and the example was iodine and tellurium. Now, Moseley came after Mendeleev, and once we knew about protons, he fixed the issues with Mendeleev's periodic table by assigning atomic numbers, and that is how our periodic table is arranged today. So again, today the periodic table is arranged by atomic number, which is your number of protons. The modern periodic law states that elements, when they are arranged by atomic number, show a repeating pattern of properties. So some classifications of elements: you have metals, nonmetals, metalloids. Metals are found to the left of the stairs, so you have that bold black line going down the steps. Anything to the left is a metal, with the exception of hydrogen. Nonmetals are found to the right and would include hydrogen. And then metalloids are found along those stairs, with the exception of aluminum. Aluminum is just a metal. We've also gone over the properties of metals, nonmetals, and metalloids back in Unit 1. So you're going to need to go back and review those notes because this is something you should have already learned. There are several family names on the periodic table, so that's what we're going to talk about next. However, what you need to know is that all families, all groups, everything in the same column has the same number of valence electrons, the same charge, so they'll gain or lose the same number of electrons, and therefore they have the same properties. So group 1 is called the Alkali Metals. They have 1 valence electron, if you were to draw their Bohr models, and so they lose that electron to become stable, to have that full outer shell, and so they form a +1 charge. Notice that in our picture here, a lot of our elements are in containers. That's because they're so reactive. They'll react with the water in the air, or they'll react with the moisture on your skin. So we don't really find them in nature by themselves. Group 2 is called the alkaline earth metals. They have 2 valence electrons, so they'll lose those 2 and form a +2 charge. Groups 3 through 12 are called the transition metals. They have 2 valence electrons. However, because they're in the D block, they can lose more than just the 2 s electrons, so they can lose different amounts of electrons. However, zinc is always +2. Zinc is always +2, and silver is always +1. So those are 2 that you should know. Everybody else, you have to be told what the charge is. These elements are also known as the B group elements, and if you look at the periodic table, they have the Roman numeral followed by the letter B. The bottom 2 rows are called inner transition metals because these bottom 2 rows should go back into the periodic table inside the transition metals. So they're inner transition metals. They go into the transition metals. And what would happen is all these transition metals would scoot to the right, and we would fit in those 2 rows. They're not in the periodic table because it doesn't allow the periodic table to fit nicely on a piece of paper, so we pull them out. The top row of the bottom is called the lanthanides because they go back in next to the element lanthanum. The bottom row is called the actinides because they go back into the periodic table next to the element actinium. They all have 2 valence electrons, but just like the transition metals, they can lose different amounts of electrons. Group 17 or 7A are called the halogens. They have 7 valence electrons, which means they need to gain 1 electron to become stable, so they form a -1 charge. Group 18 or 8A is known as the noble gases. They have 8 valence electrons, no charge because they are stable. Inert is the fancy word for non-reactive, so sometimes you might hear them referred to as the inert gases. Post-transition metals are the transition metals found, or the metals found under the stairs, so it's these blue ones right here. They are post-transition metals because they come after the transition metals, so after group 12. They can also lose different amounts of electrons because they have those d electrons. Active metals are groups 1 and 2, of course not hydrogen because hydrogen is not a metal, and active just means they lose electrons easily. Representative elements are also called main group elements, so there's 2 names that we can give these elements, and on our picture here they are the green elements. They are groups 1 and 2, and then 13 through 18. So any elements in the S and P block, they're also known as the A elements. So if you look at their Roman numerals on your periodic table, they are followed by the letter A. And then finally, the charges on the periodic table. Remember that a positive charge means it lost electrons. Those are called cations. So you have that plus sign in the middle of that word. Negative charges mean they gain electrons. They're called anions. Metals always form positive charges, so metals are always cations. Nonmetals form negative charges, so they are our anions. Group 1 is +1, group 2 is +2. Groups 3 through 12 will vary, except for silver and zinc. Group 13 will form a +3 charge. Group 14 is in between, so it's either a +4 or a -4. We're going to skip over it though because we will be told what those charges are if we need it. Group 15 is -3, 16 is -2, and 17 is -1. Group 18 has no charge because again those are our noble gases that have a full valence shell. So what you need to be able to do is if I give you an element, you should be able to tell me the charge on that element. For example, if I say calcium, you should be able to see that calcium is in group 2, so calcium would form a +2 charge. It doesn't matter if you write it number sign or sign number at this level, just make sure you're including a number and a sign, positive or negative. If I asked you for the charge of sulfur, you should recognize that it's in group 16, so it forms a -2 charge. Make sure you fill out the Google form.